Okay, so today we're going to look at volume and surface area and see how they relate to each other. So again, we kind of talked about before about how we can relate a change in volume to a change in length and change in change in length to change in area. Okay, so we kind of have that relationship from before. So we're probably going to expand on that a little bit. Okay, so calculate, first of all, just do some practice here. So calculate the following. We want to know what the lengths and areas are. So when we talk about square root, the inside represents area, the square root represents side length. Okay, so we're going to have 55 squares here, okay, and square root 55 centimeters. I'm just going to leave it like that, square root 55 centimeters on the outside. Okay, we can work out the decimal values of these as well. Here's the decimal value for this. We're going to get about 7.42. Okay, so it's about 7.42 centimeters across. Here, when we square something, we take a side length and square it. So this 2.5 represents side length. Okay, and when we square it, we get 6.25. So the 6.25 represents the number of squares inside that object or that square. Okay, so we can do the same thing with volumes and side length. If I have a side length 3 centimeters, my volume works out to be 3 centimeters cubed, which gives us 27 cubes. Okay, if I have 200 cubes and I want to work out the side length, okay, I want to do square root. Okay, so cubing gives us volume, cube root gives us side length. Okay, so we end up with a side length of 5.85. Okay, so we could write it as cube root 200 centimeters. Okay, so cube root 200 centimeters, which is equivalent to 5.85 centimeters. Okay. We also want to be familiar with our cubes and cube roots without calculators, so we need to know the standards. Okay, so if we want to know the cube root of 300, well, we have to be familiar with our perfect cubes. And I'm just going to draw a number line here. So if we talk about 1, 2, 3, 4, 5, 6. Okay, so, and I'm just going to go up to 7. The cubes of those are going to be 1 cubed, 2 cubed, cube that, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is going to be 216, 7 cubed is going to be 343 or 363, I forget. Just work that out. 343. Okay, so we use those as standards to help us with cube roots. So if I want to estimate 300 cube root, I know it has to be less than 7, because 7 cubed gives me 343 cubes. It's got to be bigger than 6, because 6 cubes gives me 216 cubes. Here we have 300 cubes. So the side length works out somewhere between 6 and 7, so I'm just going to estimate 6.5. Okay, now you don't have to be very close as long as you're in between the right integral values. If we actually work this out, it's closer to, should be closer to 7, but let's check. So let's do cube root of 300 gives us 6.69. Okay, so our estimate somewhere between 6 and 7 is good enough. So when we talk about the cube root of 775 or 755, okay, that one's going to be a little bit hard. Okay, so this one here is probably a little bit bigger than what I would expect you to do without a calculator, but let's work out 8 cubed here. 8 cubed is 512. Okay, and then 9 cubed is going to be 729, and 10 cubed is going to be 1000. Okay, so we know that 755 is going to be somewhere between 9 and 10, so we're going to estimate about 9.5. If we actually work that out on our calculator, we get about 9.1. Okay, so anywhere in between is that 9 and 10 is going to be good enough. So 9.1, okay, is our actual value. This is an estimate value. Okay, for when we're estimating with a calculator, we want to just make sure we're in between the right integer values. Okay, all right.